Hey everyone, and welcome back to the channel. Today, we're doing something a little different. We're going on an exclusive behind-the-scenes tour right into the heart of Silicon Valley, to a place where the future is being built, literally. That's right, we're heading inside a top-secret AI robotics lab. Forget what you've seen in the movies. This is the real deal. We're talking about machines that can learn, adapt, and perform tasks that were once thought to be purely human. What does it really take to create a robot that can see, understand, and interact with the world around it? What are the biggest challenges these engineers are facing right now? And what mind-blowing breakthroughs are just on the horizon? We're about to get answers to all these questions and more. So, buckle up, because you're about to get a front-row seat to the future of technology. Let's go. All right, we've just stepped through the doors, and the energy in here is absolutely electric. This is the main development floor, and as you can see, it's a beehive of activity. On our left, we have the hardware team. These are the folks who design and build the physical bodies of the robots. It's a fascinating mix of mechanical engineering, material science, and pure artistry. They're constantly experimenting with new alloys and composites to make the robots lighter, stronger, and more agile. Every single joint, every wire, every sensor you see has been meticulously designed and tested countless times. Look over here, this is a robotic arm prototype. Notice the fluidity of its movement. The engineers explained that they take inspiration from the human musculoskeletal system to achieve this level of grace and precision. It's not just about bolting parts together, it's about creating a seamless integration of form and function. This is where the physical meets the digital. Now, let's move over to this section. This is where the magic really starts to happen. The perception team. A robot is just a piece of hardware if it can't perceive its environment. This team is responsible for giving the robots their senses. We're talking about state-of-the-art computer vision systems that act as the robot's eyes. They use a combination of high-definition cameras, LiDAR sensors, which use lasers to create 3D maps of the room, and infrared sensors. The real challenge isn't just collecting this data, it's helping the robot make sense of it all in real time. Look at this monitor here. It shows what the robot is seeing. You can see it identifying objects, a chair, a table, a person. It's even estimating their distance and trajectory. This ability, called simultaneous localization and mapping, or SLAM, is what allows a robot to navigate a room it's never seen before without bumping into things. It's incredibly complex, and these engineers are pushing the boundaries of what's possible every single day. Of course, seeing is one thing, but understanding is another. That brings us to the core of it all, the AI and machine learning team. These are the brains behind the brains of the robots. They write the complex algorithms that allow the robots to learn from their experiences. This is where reinforcement learning comes into play. Imagine teaching a dog a new trick. You reward it for good behavior. It's a similar principle here, but on a massive computational scale. The real challenge is creating a robot that can handle variability. What if the bolt is slightly different? What if the lighting changes? What if an object is partially obscured? Humans do this without thinking. We want our robots to have that same level of adaptability. But we're redeveloping AI models that can generalize from a few examples to perform a wide range of tasks in unstructured real-world environments. It's about moving from a specialist robot to a generalist robot, one that could potentially help in homes, hospitals, or disaster relief scenarios. It's a huge leap, and it's what we're passionately working towards. That's absolutely fascinating. So it's not just about programming a robot for one job, but teaching it how to think and adapt to new situations. Thank you, Aris. That brings up a crucial point: safety. A powerful, adaptable robot needs to be an incredibly safe one. This lab has a dedicated ethics and safety team that works alongside the engineers from day one. They run countless simulations to try and break the robot's logic, to find edge cases where it might behave unpredictably. They program in strict safety protocols, like force sensors that stop the robot's arm if it encounters unexpected resistance, preventing it from causing harm. There are also clear no-go zones and rules hard-coded into the AI's foundational model. The conversation around AI ethics is paramount here. The goal is to ensure that this technology is developed responsibly and for the benefit of humanity. It's a continuous dialogue between engineering, philosophy, and public policy. Let's take a look at a real-world application they're testing. Over in this enclosed area, they're simulating a kitchen environment. Here we have their flagship robot, which they've nicknamed Helios. Watch this. An engineer just gave a simple verbal command: Helios, please grab the red apple from the bowl. The robot's cameras scan the table. Its AI identifies the different fruits, isolates the red apple, and calculates the best path to pick it up without knocking over the bowl or anything else. Its gripper, designed to mimic the gentleness of a human hand, carefully picks up the apple and places it on the counter. It seems simple, but the amount of computation and engineering that went into that one action is staggering. They're training it to handle more complex requests, like "make me a cup of coffee," which involves a whole sequence of actions: finding the mug, operating the coffee machine, and handling hot liquids. This is a glimpse into a future where robots could assist the elderly or people with mobility issues, giving them greater independence. But it's not all smooth sailing. The engineers told me about the countless failures they encounter. That's a huge part of the process. For every successful demonstration like the one we just saw, there are 1,000 failed attempts in the simulation log. Robots dropping things, misidentifying objects, choosing inefficient paths. They call it rapid iteration. Every failure is a data point. It's an opportunity for the AI to learn what not to do. This culture of embracing failure is actually key to their success. Instead of getting discouraged, they analyze the data from the failure to refine the algorithm. It's a relentless cycle of building, testing, failing, learning, and improving. It really shows the resilience and dedication required to work on the cutting edge of technology. It's not about being perfect the first time. It's about having the persistence to get it right in the end. So, what's next? What does the future hold for this lab and for AI robotics in general? According to the team lead, the next 5 to 10 years will be transformative. They're working on making the hardware cheaper and more accessible. They envision a future where platforms are more open, allowing developers from all over the world to build applications for them, much like the App Store for our smartphones. The focus will continue to be on making robots more collaborative, able to work safely alongside humans in dynamic environments, not just in cages on a factory floor. We're talking about cobots in warehouses, assistants in surgical rooms, and companions in our homes. The ultimate dream. A robot that is not just a tool, but a true partner. One that can anticipate our needs and help us solve some of the world's most pressing challenges. It sounds like science fiction, but standing here, you can't help but feel that it's closer than we think. As our tour comes to an end, I'm left with a profound sense of awe. It's one thing to read about AI and robotics, but it's another thing entirely to see it come to life, to meet the brilliant minds who are architecting this future. It's a world of complex code, intricate hardware, and a relentless pursuit of innovation. But more than that, it's a story of human ingenuity and our unyielding desire to create and explore. What we saw today wasn't about building servants, but about creating partners to augment human potential. The road ahead is long and full of challenges, both technical and ethical, but the passion and optimism in this lab are contagious. The future is being built right here. One line of code, one gear, one successful trial at a time. Thank you so much for joining me on this incredible journey inside one of Silicon Valley's most advanced AI robotics labs. I hope you found it as fascinating as I did. What did you find most surprising or exciting? Let me know in the comments below. And if you enjoyed this deep dive into the world of future tech, make sure to hit that like button and subscribe to the channel so you don't miss our next adventure. Thanks for watching, and I'll see you in the next one.